Okay, so today we are talking about equations from tables, which means you're going to be given a table and you're going to be asked to write an equation to represent what's happening in the table. So if you remember, we've been talking about these types of tables in our x and our y, and you'll remember that your x is your independent variable and your y is your dependent variable. And this is an input-output situation. So your x is your input, your y is your output. So something is happening to the x. You could think of it being right here in the middle. Something is happening, and out comes this y. So this is an input-output situation, and we have to ask ourselves, what is happening to x to get y? So you're not looking what's happening from here to here to here. You're not looking at what's happening here to here to here. You are looking from x to y. What is happening? So it can be additive or multiplicative, like we talked about a few days ago, or it can also be subtraction or division in this case. So we're going to look at all different types. And so when you're starting with a number and then you're getting a smaller number, you know you're either dividing or subtracting. There's nothing I could divide 12 by to get 10, but I could take away 2. 11 minus 2 is 9, 10 minus 2 is 8, 9 minus 2 is 7. So we know that the rule here is minus 2. So what we're learning, I know all of y'all can do that. Y'all did that in elementary school. Your goal here is to be able to write an equation. These always start with y equals. If you see an answer choice that says x equals, you can automatically get rid of that one. They always start with y equals because y is your output, so that's the answer. And then something is happening to x. So x is either going to be adding something to it, subtracting, multiplying, or dividing. And in this case, it's subtracting. So it's x minus 2. These over here, the y's, equal these minus 2, x minus 2. Let's look at another example. Again, we've got our input and our output, and something is happening to that x to get that y. And it's getting bigger this time, so we know we're either adding or multiplying. I can add 1 to 1 to get 2, but 2 plus 1 is not 4, so that's not going to work. So the other way I could do that is I could multiply by 2. 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, and so on. So our rule here is that we are multiplying by 2. Remember that your equation always starts with y equals, and since we're multiplying by 2, the way we show that with a variable is to put it right next to the variable. So again, our y's, these numbers here, equal 2 times these numbers here. So 2 times x. I wanted you to also see some tables that go the other direction. So sometimes the table that you see in a problem will be horizontal like this. Same thing though, your x is still your input, your y is still your output, and you're still looking at what's happening to the x to get the y. So again, you're not looking here. Some people look at this and they say, oh, it's going up by 5. That's not what we care about. We care about what's happening to x in order to get y. And it's getting smaller. And if you look, what's happening is that it's being divided by 5. 15 divided by 5 is 3, 20 divided by 5 is 4, and so on. So when we go to write our equation, we know it starts with y equals, and so x is being divided by 5. And so we show that as, with that fraction bar, x divided by 5. Or another way of showing that is y equals 1/5 x. I see it like this more, but this means the same thing because if you find a fifth of something, 1/5 of something, you're dividing that in 5. Just like if you find half of something, you're dividing it in 2. Last example for today. Again, we've got our input and our output. What's happening to x to get y? It's getting smaller, it's getting bigger. 0 plus something